Hi everybody, today we're going to talk about quadratic functions, and the first thing I think you're going to notice is that we've talked about quadratic functions before. We've used them to do transformations, but today we're just going to look a little bit closer at quadratic functions and look at some properties they have that we haven't really used yet. So let's start by giving a definition. A quadratic function can be written in the form f of x equals a times x minus h squared plus k, and hk is the vertex. I want to call attention to this a to start and say a is going to tell us a lot of information about our quadratic or parabola, whichever one you want to call it. When a is positive, we're going to know that f of x opens up. It will look something like this, and that will give us a minimum at this vertex of hk. When a is negative, then we know it's going to get reflected and it's going to up and down, and then it will have a maximum at hk. So just this little picture tells us a lot about our quadratic. So let's start just by finding the vertex and state if it's a max or a min. So I have f of x is 3 times x minus 2 squared plus 4. So my vertex is going to be at 2, 4. Because 3 is positive, I know that this quadratic opens up, so this vertex of 2, 4 will be a minimum. Also notice this 2 from the x minus 2 feels like it switched places. It was negative and now it's positive, so you should always see that happening as you're looking for the vertex, that what's in parentheses, you change the sign, and then what's outside the parentheses, you don't change the sign. This time I have f of x is negative 5 times x plus 1 squared minus 2. So let's start with the vertex. The plus 1 becomes negative 1. The negative 2 stays as negative 2. The a this time is negative 5. A negative says I had a reflection, so now it's opening down. That makes this vertex a maximum. So let's add some more stuff to this quadratic, and we're going to start with the axis of symmetry. What I want you to think about is x squared is an even function, and even means I have the same thing on the right and on the left. So there's this repetition of the function, and the symmetry, when we're looking at even functions, is talking about being symmetric to the y-axis. So what's on the right side of the y-axis is the same side as the left of the y-axis. As we do transformations, we're going to retain symmetry, but where the function's symmetric is going to change. So it won't be symmetric to the y-axis. It's going to be symmetric to a line x equals h. So x equals h is a vertical line that goes through the vertex. As you're writing the axis of symmetry, it's really important that you always write it as an equation. So never just telling a number, you always want to say x equals a number. All quadratic functions do have a line of symmetry, so there's never a time that you're not going to have one. Important features to look at with this even function says, when I have x-intercepts, they should be the same distance away on the right and the left of this axis of symmetry. So when I look, that kind of is a nice little verification of they should be an equal distance on each side. The same kind of thing, the y-intercept will have a duplicate number, so there'll be another number on the graph that has the same y-coordinate as the y-intercept. It will be the same distance away from the axis of symmetry as the y-intercept. So kind of a nice way to verify that you did the graph right. It also gives you multiple points to use when you're trying to graph the function. So let's try. F of x is x minus 1 squared minus 9. So I'm going to start asking for a lot of things. The vertex, axis of symmetry, intercepts, domain, and range. A couple of these things will be really easy, like the vertex. I can see the vertex is at 1, negative 9. Let's go ahead and also add in there that this is opening up, so I know this is a minimum. This is really helpful because it helps us answer the question about domain and range. Domain of all quadratics is negative infinity to infinity. The range is going to change, and knowing this vertex is going to be really helpful. So having a minimum value for our vertex says the smallest it'll ever be is negative 9. So I'm going to write negative 9, and it goes to infinities. Let's go ahead and answer the axis of symmetry. Axis of symmetry, which often we write as AOS, is x is equal to 1. Then to do my intercepts, well, I have two intercepts. Let's do the easy one first, the y-intercept. The y-intercept comes from calculating f of 0. So I have 0 minus 1 squared minus 9. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 minus 9 is negative 8. So I have a y-intercept at 0, negative 8. And then my x-intercepts. I get that from setting the whole function x minus 1 squared minus 9 equal to 0. This says x minus 1 squared is 9, and you know we're going to take the square root. Super important, when you take the square root, x minus 1 is going to be positive or negative 3, so 2 solutions. I'm going to separate that into x minus 1 is positive 3, x minus 1 is negative 3. This says x is 4, this says x is negative 2, so I have 2.40 and negative 2, 0. Now we want to add all of this information to our graph. The first thing I noticed is I didn't give myself enough room on this graph, and I'll just do my best to draw this in by hand. My line won't be perfect, but I'm going to skew it a little to give myself extra room to get to this negative 9. So go over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is negative 9, so 1, negative 9. Here's my vertex. From there, I'm going to use my X-Intercepts. So I have 1, 2, 3, 4. Here's an intercept, and then I have negative 2. Here's another intercept. My Y-intercept was negative 8. And if we wanted to, a nice thing we can do is go ahead and put in the axis of symmetry. And I'm going to put that in as a dashed line. So we put it in as a dashed line because it's not part of the function. It's kind of a guiding line to help us draw. And I'm just going to say if I had a point 1 to the left of the axis at negative 8, then I'm going to have a point 1 to the right of the axis at negative 8. So that symmetry helps me draw. You can also count. I had 1, 2, 3 that got me to the x-intercept. I have 1, 2, 3 that got me to the x-intercept. So I can see that symmetry helping me there as well. All right, now we're going to connect the dots. This is the worst part for me because I'm not a very good artist, but you'll get the overall idea, and I promise I won't draw them all. Try it again, a little different graph. I have f of x is negative 2 times x plus 3 squared plus 8. Like last time, we'll start with our vertex. It's going to be negative 3, positive 8. I have a negative 2, which tells me this is flipped upside down, so this now is a maximum. My axis of symmetry, AOS, is x equals negative 3. It always matches the h-coordinate from the vertex. Let's talk about domain and range. The domain is negative infinity to infinity. And then the range, the maximum it's going to be is positive 8. So I want to say negative infinity until 8 and then a square bracket. I wrote find the y-intercept, but in actuality, I want to find all intercepts. So let's do f of 0 is negative 2 times 0 plus 3 squared plus 8. So this is negative 2. 3 squared is 9 plus 8. So I have negative 18 plus 8 is a negative 10. To get my x-intercepts, I'm going to take negative 2 times x plus 3 squared plus 8, set it equal to 0. First step is move the 8 over, so I have negative 2 times x plus 3 squared is negative 8. When I divide by 2, I get x plus 3 squared is 4. I'm going to take the square root of both sides, so square root of x plus 3 squared, square root of 4. I have x plus 3 is plus or minus 2. So if x plus 3 is 2, then x is negative 1, so I have the point negative 1, 0. If x plus 3 is negative 2, then x is negative 5, so I have negative 5, 0. Let's draw this graph. Now let's look for 1 second at what our vertex was. It's negative 3, 8, so I know I need some space to draw the 8. And I also had a y-intercept that was negative 10, so I kind of want to make sure I get all that onto my graph. So 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's start with the 1, 2, 3, negative 3, positive 8. There's my vertex. Let's put in the x-intercepts. I have 1 at negative 1, and I have 1 at negative 5. I'm going to draw that axis of symmetry in so I can show you 2 on the right, 2 on the left is equal. Our other point that we want to put in is our y-intercept, and remember that was way down here at negative 10. I'm 1, 2, 3 over, so 1, 2, 3 over. If I want to go one more and put another dot, I could. It might help us draw. So I'm just going to try to connect these dots the best that I can, right? Thank goodness for technology. One more. This one has a little twist to it. This says list the vertex, axis of symmetry, intercepts, domain, and range. So, like the last couple, I'm going to start with the vertex, which is 1, positive 3. It's going to open up, which means it has a minimum. And the minimum value would be 3. So when I look at the domain, it's negative infinity to infinity. And when I look at the range, it's 3 to infinity. Now, I want to point that out right now just to kind of show you something really quick. Let's put in 1, 1, 2, 3. I want you to picture, here we are at 1, 3, and I know I'm opening up. I'm going to draw and then erase. I'm not going to have x-intercepts on this particular graph. When I'm looking at the point that 3 is my minimum and I'm going up, there's no way that it's ever going to have a value where y is equal to 0. So a little bit in my head, I say right now, x-intercepts, none. Saves me time. You could try to solve the equation of 5 times x minus 1 squared plus 3 equals 0, and at some point you'll get to some complex numbers. I think it saves you steps if you try to draw this out a little bit and don't rely on always solving the equation. We will still have a y-intercept, which means I'm going to do 5 times 0 minus 1 squared plus 3. 0 minus 1, negative 1, squared is 1, times 5 is 5, 5 plus 3 is 8. Let's erase my little drawing so we can put in, this is 3, 4, 5, 6, 7, 8. So here we are, way up here at 8. Let's say our axis of symmetry, which is x equals 1. And now we can finish off the graph. Now notice this time I only have 2 points. I have a y-intercept and I have the vertex, which makes this axis of symmetry really helpful. When I put in the axis of symmetry, I compare that I went 1 to the left and I was up here at 8. So if I go 1 to the right, I will have a second point. These 3 points help me draw this curve with some kind of accuracy. So let's change what we're doing. Instead of me giving you the function and us talking about it and graphing it, let's go the opposite way where we have a function and I want to know what it is. I would start by looking at the vertex. So this vertex is 3, positive 1. I know my function generally then looks like a times x minus 3 squared plus 1. So we don't want to make assumptions about a. We want to go and look for it to make sure we understand what it is. So the easiest way for us to do that is we're going to take this y-intercept and use that. And how I'm going to use it is I'm going to say if I calculate f of 0, which is a times 0 minus 3 squared plus 1, I'm supposed to get 7. So this says I have a, negative 3 squared is 9, plus 1 is 7. So that says 9a. I can move the 1 over and get 6. So a is 6 over 9, which we can reduce to 2 over 3. So this function is 2/3 of x minus 3 squared plus 1. Let's try that again. This time you can see I have a vertex at 1, negative 9, and I have a y-intercept at negative 8. So I'm going to start as f of x is a times x minus 1 squared minus 9. If I put in 0, I have a times 0 minus 1 squared minus 9, and that should be a negative 8. Negative 1 squared gives me 1, so I just have a minus 9 is negative 8. I move the 9 over, and I get a is 1. So this function is just x minus 1 squared minus 9. Let's try one more. This time it's turned upside down, so we expect a to be negative when we finish. I can see the vertex is negative 2, 4, so I have f of x is a, which I don't know, x plus 2 squared plus 4. If you're looking, you see a couple of different points. So we have a vertex way down at the bottom at negative 8, but we also have a point at negative 1, 1 and a point at negative 3, 1. So let's use one of those points this time just to show you how to do something different. So if I do f of negative 1 is a times, I'm putting in negative 1 plus 2 squared plus 4, I should get a positive 1. Input, output. Let's simplify that. That says f of negative 1 is a, negative 1 plus 2 is 1 squared plus 4 should be 1. Let's drop the f part and just say this says a plus 4 is negative 1, so a is negative 3. F of x is negative 3 times x plus 2 squared plus 4. If you wanted to check it, maybe one thing you could do really quick is compute the y-intercept. I would have negative 3 times 2 squared plus 4. This is negative 12 plus 4, which is negative 8. And you're like, oh, that's exactly what I expected to get. So you say, good job, and keep going. So let's change the way it looks, and let's only ask what the vertex is now. I'm not going to graph it. So I have f f of x is x squared plus 8x. Now notice the format has changed. I don't have x minus h, but I need to get it that way for me to be able to tell you what the vertex is. So what we have to do is complete the square. So I'm going to say I have x squared plus 8x. And remember, we take the number in front of x, we divide it by 2, and we square it. Now, back when we first started doing completing the square, if I added something, I would add it to both sides, and that's how I solved the equation. Now that I have a function, I don't really want to add it to both sides, so what I'm going to do instead is add it and subtract it. The idea is by adding it and subtracting it, I haven't changed the value of the function, I just changed the look of the function, but it allows me to complete the square. So x squared plus 8x plus 8 over 2 squared becomes x plus 4 squared, minus 8 over 2 is 4, 4 squared is 16. So now I can see the vertex is negative 4, negative 16. That's a little tricky, so I think we need to do it a couple times. The next one says f of x is x squared minus 4x minus 5. So same start. I take x squared minus 4x. I add negative 4 over 2 squared. And then I subtract negative 4 over 2 squared. And then I still have my minus 5. So you want to make sure you always equal it out. So add and subtract. This whole front part, x squared minus 4x minus 4 over 2 squared becomes x minus 2 squared, minus negative 4 over 2 is negative 2, negative 2 squared is 4, minus 5. Now I have x minus 2 squared minus 9, so that says my vertex is 2, negative 9. So I have some good news for you. There is an easier way to find the vertex, and you don't have to do completing the square. What you do instead is if I have a quadratic function, ax squared plus bx plus c, I can find the vertex by finding negative b over 2a, f of negative b over 2a. It is much easier than it sounds. So let's start with this one. F of x is 2x squared minus 12x plus 4. Negative b over 2a is negative 12 over 2 times 2. So the negative 12 was my b, the 2 is my a, so negative 12 is 12, 2 times 2 is 4, so that says that I have 3. This 3, this is my h. To find the k, I'm going to do f of 3. The h and the k are a point, so when I put 3 in, I will get the value of the k. So we're going to do 2 times 3 squared minus 12 times 3 plus 4. 3 squared is 9, so I'm going to have 2 times 9. 12 times 3 is 36 plus 4. I have 18 minus 36 plus 4. This is negative 14. So my vertex is positive 3, negative 14. Let's do one that has a fraction. I have negative 1/5 x squared plus 3x minus 2. Negative 1/5 is a, 3 is b, and then c, even though we don't really use it, is negative 2. I start with negative b over 2a. I have negative 3 over 2 times negative 1/5. This is negative 3 over, let's do parentheses, negative 2 over 5. Remember, when I divide by a fraction, I multiply by the reciprocal. Also, a negative negative becomes a positive. So what do I really have? I have 3 times 5 over 2. 15 over 2 is 7.5. Now we're going to find f of 7.5. This is negative 1/5 of 7.5 squared plus 3 times 7.5 minus 2. This gives me 9.25. So my vertex is 7.5, 9.25. So let's go back to listing our vertex, axis of symmetry, intercepts, domain and range, all of that, but let's use this new format where it doesn't have to be in the form a times x minus h squared plus k. So this time I have f of x is negative x plus 4 times x. I'm not ready to do the vertex, I'm not ready to do the axis of symmetry, but I could tell you the intercepts. So f of 0 is negative 0 plus 4 times 0, which is just 0. So I have a y-intercept at 0, 0. The x-intercepts, I would take negative x plus 4 times x, make that 0. The negative you can drop. This says x is negative 4, x is 0. So negative 4, 0, 0, 0, are my x-intercepts? I know the domain because I always know the domain. It's negative infinity to infinity. But before I can talk about the range, I need to find out the vertex. So let's say that this function, negative x plus 4 times x, is negative x squared minus 4x. I want you to imagine when you distribute this x that you make it negative x. That way you push the negative through and you push the x through. To find the vertex, I'm going to do negative b over 2a. So I have negative 4 over 2 times negative 1. Negative 4 is 4. 2 over negative 1 is negative 2. So I have an x-coordinate of negative 2. Now I'm going to find f of negative 2. This is negative 2 plus 4 times negative 2. Here's a negative. Negative 2 and 4 is 2 times negative 2, positive 4. So my vertex is negative 2, positive 4. This would also be the axis of symmetry, which is x is negative 2. So I get a lot of information from finding the vertex. Now I haven't left myself a lot of room to graph, but I think I can still do it. So negative 2, 1, 2, 3, 4. Here's my vertex. Because it's negative, I know it's opening down. Let's add in here that the range is negative infinity to positive 4, close bracket. I have two intercepts. I have 0 and I have negative 4. The reason I don't have 3 is because the y-intercept of 0, 0 is the same as the x-intercept of 0, 0. So having that repetition between the x and the y means I only have 2 intercepts this time. If you want to draw on the axis of symmetry, you might find it helpful, and then I'm just going to connect the dots. Let's look at that graphing with technology, because your homework is not going to be drawing by hand, it's going to use a tool. So I'm doing the same problem we just did, that y equals negative x plus 4 times x, and we said we know this opens down. We found our x-intercepts at negative 4, 0 and at 0, 0, and we said the vertex was negative 2, positive 4. The equation of the axis of symmetry is x equals negative 2. And then to draw, I'm going to grab this parabola, and I want to start at the vertex, so negative 2, positive 4. And then I'm going to use the x-intercept to help me find another point. So you're always going to have to put on multiple points, so you might as well use something that you already know. Let's submit all parts. And you can see that we did a great job. So I think the best part of quadratics is all the different kinds of applications that I have, and I'll go through several just to give you an idea of what to expect. So we're going to start with one that's revenue. The revenue for selling a clothes dryer can be modeled by the function r of p is negative 4p squared plus 4000p. What price maximizes the revenue? So maximizing, you're thinking this opens down, so the maximum is at the vertex. So I want to find negative b over 2a. You'll find that that's your most common go-to when you're trying to maximize or minimize a quadratic function. So I have negative 4,000 over 2 times negative 4. I have 4,000 over 8. So I canceled the negatives and I multiplied 2 by 4. This says 500. This gives me the price. If it happened to ask you for the revenue, you would just plug it back in. Next question says a ball is thrown upward and outward from a height of 4.5 feet. The height of the ball, f of x in feet, can be modeled by f of x is negative 0.1x squared plus 1.4x plus 4.5, where x is the ball's horizontal distance in feet from where it was thrown. What is the maximum height the ball is thrown? So again, we're thinking about maximizing it. Now, watching this one, x is the horizontal distance, so it tells me right or left. F of x tells me the height, so this time I want the y-coordinate or the f of x coordinate for where the ball is thrown, so that's where I need to find the k for the vertex. So I need to do negative b over 2a, which is negative 1.4 over 2 times negative 0.1. Again, you can make this 1.4. This is 0.2, which gives us 7. Now we're going to find f of 7. This is negative 0.1 times 7 squared plus 1.4 times 7 plus 4.5. This gives me 9.4. So the maximum height of this ball is 9.4 feet. Same problem, let's just answer another question. It says, when will the ball hit the ground? So if you're thinking about it, it started at 4.5, it went up and it went down, right? So here's the 4.5, here's it went up to 9.4, and sometime it's going to hit the ground. So when it hits the ground is when the height is 0. So I want to set negative 0.1 x squared plus 1.4x plus 4.5 equal to 0. Now this one doesn't look too great. I have decimals everywhere. So what I think to do is go straight to the quadratic equation. So x is going to be negative b 1.4 plus or minus the square root. I have 1.4 squared minus 4. A is negative 0.1. C is 4.5 all over 2a, which is 2 times negative 0.1. This says x is equal to negative 1.4 plus or minus. Let's figure out the discriminant. What's underneath the radical? I got 3.76, and then in the denominator I have negative 0.2. So I'm going to do this twice. I'm going to do negative 1.4 plus the square root of 3.76 over negative 0.2, and I'll do negative 1.4 minus the square root of 3.76 over negative 0.2. The first one gives me negative 2 point, let's call it 7, and I'm just going to say it can't be that answer. I can't have time that's negative, it would have to be positive, so we get to throw that one away. Then I do negative 1.4 minus the square root of 3.76 divided by negative 0.2. That gives me a positive, I'm going to call it 16.7. So go back to the problem and it says, when will it hit the ground? Well, it'll hit the ground when it's 16.7 feet from where we started. So there's our answer for the second part. Then just as a quick graph, and I'm only going to make it really quick, we said we started at 1, 2, 3, 4, 5 at 4.5, 6, 7, 8, 9.4. It hit its height, and that was at 1, 2, 3, 4, 5, 6, 7 feet from where it started. And then it hits the ground at about 16.7. So it went up, and then it went down. Not the best graph, but you get the idea of the arch. So let's add a little bit more. Let's do this word problem where we have 600 feet of fencing, and we want to know the largest rectangular area that can be fenced in if you place the fence against the side of a large building. Typical problem you're going to see is like you have some big building and you want to fence a little piece of it. So you're having to put the fence only on this part because you already have a wall on one side. So it kind of saves us money. So what we see is we have two sides that are going to be the same, and then a third side that's a little bit different, and its length is the same as what it is touching the building. So what we say here is perimeter-wise, 2x plus y is 600 feet, and the area it encloses is xy. The trick is we only want to have one variable, so I'm going to change this 2x plus y as 600 to y is 600 minus 2x. Now I can substitute that 600 minus 2x in for a, so I have x times 600 minus 2x. So let's start by distributing. I have 600x minus 2x squared, and that looks a little weird to me. I like things to be in descending order, so I'm just going to flip that around real quick. Now it looks like a quadratic, so I can do negative b over 2a. So negative b is negative 600 over 2 times negative 2. That says x is 150. This is feet. To get y, I go back to 600 minus 2x. So 600 minus 2 times 150 says y is 300. Still haven't answered the question. The question says, what's the biggest area we can fence in? To get that, we need to multiply 150 by 300, which says we can fence in 45,000, let's say, square feet. So it wouldn't be a talk about quadratics if we didn't do some kind of bridge problem. So I totally made this one up, so it's not to scale, but I just grabbed a picture of a bridge and I threw some numbers on it. So let's pretend it works. So I said, find the equation for the arch of a bridge given its horizontal span is 120 feet. So let's write that in as we go. So this is 120 feet. It has a height of 45 feet above the water. So here we're going 45 feet. And the lowest point is 5 feet above the water. So I'm telling you this is 5 and this is 5. Okay, so we have a lot of components that are going to help us write this equation. Generally, what I'm thinking is f of x is a times x minus h squared plus k. The first thing I know is k. This height, where the vertex is 45. So I can immediately write f of x is a times x minus h squared plus 45. We have a little bit of a hint about some other things. I know a is going to be negative, but I'm not sure what the value is yet. So these other points, like 5 above the water and 120 feet span, is really going to help us. What we're thinking is, what if we decide we're going to make this symmetric to the line x equals 0, which is the y-axis. So when I look at 120 feet, I know I'm going 60 to the right and I'm going 60 to the left. And at this point, 60 on the right, it is 5 up. And at this point, 60 on the left, it is 5 up. So I know 2 points. So this says if I do f of 60, I'm going to get a times, well, all of a sudden, h now is 0. So I know that this is 0.45. So that helps a lot. Now I know h and k. Only thing I don't know is my a. So I'm going to write 60 minus 0, don't need that, squared, plus 45. What do we know this value is supposed to be? It's supposed to be 5. If I plug in 60, I should be only 5 feet above the water. So this is a times 60 squared plus 45 equals 5. So we just need a couple more steps. 60 squared is 3,600. I have times a. I'm going to move the 45 over, so now 5 minus 45 is negative 40. I can divide by 3,600. So that simplifies down to negative 1 over 90. Now we have that our function is negative 1 over 90, x squared plus 45. So I hope that gives you a really great overview of quadratic functions, shows you a few places where it is used. Make sure you make use of this negative b over 2a. I think you're going to find it extremely helpful. Good luck.